Question 1. From the perspective of database migration planning, Mr. Alvarez is tasked with moving a mission-critical on-premises database to OSI. The database has high availability requirements and minimal downtime tolerance. Which approach should he prioritize? A. Lift and shift the database with minimal testing. B. Implement Oracle Zero Downtime Migration (EDM) for an online migration. C. Export data using Data Pump and import it into OSI manually. D. Take an offline RMAN backup and restore it during maintenance windows. Answer. Correct answer. B. Explanation. Online migration using Oracle Zero Downtime Migration (EDM) is optimal for mission-critical databases with minimal downtime tolerance, as it automates pre-migration, migration, and post-migration tasks, ensuring continuous availability. Lift and shift may introduce downtime and risk for high-availability systems. Data pump export import, while useful for logical migrations. Application downtime. Offline RMAN restore is reliable but entails longer downtime and is less suitable for critical systems requiring minimal disruption. CDM's automation reduces human error and ensures seamless replication and validation. Question 2. Considering the evidence Iscapor needs to migrate a large, multi-terabyte database from an on-premises environment to OSI, the available network bandwidth is limited and she must minimize the transfer window. Which solution is most appropriate? A. Use Oracle Data Pump for full export-import over the network. B. Employ the data transfer appliance to physically ship the data. C. Perform an RMAN backup and restore over VPN. D. USUL developer migration tools for the entire database. Answer. Correct answer. D. Explanation. Using SUL developer for large-scale database migrations is generally impractical due to network constraints, as it is designed for smaller or non-Oracle databases. Data pump over a limited network can be slow and risk extended downtime. RMAN or VPN is feasible but could be time prohibitive for multi-terabyte datasets. The data transfer appliance is the most appropriate solution for very large databases because it physically transports large volumes of data, reducing dependency on bandwidth and minimizing migration time while ensuring data integrity during transport. Question 3. While examining migration evaluation considerations, Mr. Chen realizes the source database uses a character set incompatible with the target autonomous database. What should be his primary concern? A. Downtime scheduling. B. Data type conversion errors. C. Character set conversion and data integrity. D. RMAN backup retention. Answer. Correct answer. C. Explanation. Character set incompatibility can lead to data corruption or loss during migration, making conversion and validation essential. Downtime scheduling is secondary to ensuring the data remains accurate. Data type conversion errors are relevant but less critical than the character set integrity issue. RMAN backup retention ensures recoverability but does not address the core problem of mismatched encoding. Careful pre-mig assessment and testing using tools like CPAT or data pumps conversion options mitigate risks of character set conflicts and preserve data integrity during migration. Question 4. Given the circumstances, Mr. Thompson is migrating a EEM on-premise CDE to an OCDE. Which migration technique aligns best with multi-tenant architecture principles? A. Full RMAN restore of the entire CDB. B. Data pump export import of the PDB. E. PDB unplug plug into the TARC CDB. D. Manual SQL script replication of all objects. Answer. Correct answer. C. Explanation. Unplugging EUMM the SUCDB and plugging it into the TARC CDB leverages the multi-tenant architecture, maintaining container isolation while minimizing disruption. Full RMAN restore of the entire CDB is unnecessary if only a single PDB is migrated and can increase complexity. Data pump can work but requires logical migration steps that are slow and prone to errors with large EEBs. Manual SUL scripting is labor-intensive and error-prone. PDB unplug preserves metadata, privileges, and object definitions efficiently, respecting the Oracle multi-tenant design principles. Question 5. In the context of data integration, Rivera needs to capture real-time changes from an on-premises old system to an OSI autonomous data warehouse. Which approach best meets this requirement? A. Full data pump export import nightly. B. Oracle Golden Gate for Change Data Capture CDC. E. Almanac-Prestor during maintenance windows. D. Manual settle using flat files. Answer. Correct answer. C. Explanation. Almanac-Prestor is suitable for physical migration but does not support real-time replication. Full data pump export import and manual ETL are batch-oriented and cannot provide immediate propagation of changes. Oracle Golden Gate is the most effective solution for real-time replication, leveraging change data capture to continuously propagate database changes to the target. It ensures minimal latency, consistent data, and supports zero downtime migration scenarios. This approach maintains transactional integrity and synchronizes source and target systems without interrupting business operations. Question 6. Throughout the course of a migration project, Mr. Patel notices that the target OSI autonomous database is experiencing slower performance post-migration. Which factor should he examine first to optimize performance? A. In policy configuration. B. Data pump parallelism and network throughput. C. Database licensing model. D. Audit trail settings. Answer. Correct answer. D. Explanation. Audit trail settings, while relevant to compliance, are less likely to impact overall database performance than other migration parameters. In-policy configuration controls access but does not affect query efficiency. Database licensing affects costs but not runtime performance. Optimizing data pump parallelism, network throughput, and tuning post-migration parameters is critical to achieving expected performance. Evaluating these factors ensures efficient bulk loading, reduces bottlenecks, and aligns the migrated system's resource usage with OSI's best practices for high-performance autonomous databases. Question 7. By evaluating Oracle Cloud Database Services, Isnuen must select a service for a mixed workload that requires autonomous scaling, built-in patching, and analytics capabilities. Which service is most appropriate? A. Base database service with manual management. B. Autonomous transaction processing app database. C. Managed standby database. D. SQL developer managed on-premises clone. Answer. Correct answer. B. Explanation. Autonomous transaction processing app is designed for mixed workloads requiring automation, elastic scaling, built-in patching, and analytics. Base database service provides flexibility but requires manual management of scaling and maintenance, increasing operational overhead. Unmanned standby databases are primarily for disaster recovery, not for active mixed workloads. SQL developer managed on-premises clones are not cloud-native and lack the automation features of OSI services. App reduces operational complexity, ensures optimized resource allocation, and aligns with cloud best practices for hybrid workloads. Question 8. When faced with migration planning, ISTA must choose between logical and physical migration methods. Which scenario most clearly justifies using our man-based physical migration? A. Small non-critical test database with minimal downtime requirements. B. Large production database needing exact binary replication to OSI. C. Cloud-native database already optimized for JSON workloads. D. Migrating only, a few tables for reporting purposes. Answer. Correct answer. C. Explanation. Migrating a small test database or a few tables is better suited to data pump or SQL developer for logical migration. Raman physical migration is ideal for replicating large, complex databases where binary-level accuracy, complete object fidelity, and point-in-time recovery are critical. Migrating a cloud-native database already optimized for specific workloads may not benefit. Physical migration. Logical methods are more flexible for partial data migrations or heterogeneous environments. Physical migration ensures consistency, reduces transformation overhead, and preserves exact database structure for full-scale production environments. Question 9. According to recent studies, Santos is responsible for integrating multiple heterogeneous data sources into an OSI autonomous database for analytics. Which approach balances transformation efficiency and scalability? A. Manual ETL via SQL crypts. B. Oracle data integration mappings with ELT architecture. C. Offline RMAN restore followed by SQL adjustments. D. Data pump full export import. Answer. Correct answer. B. Explanation. Oracle data integration with ELE architecture is designed for scalable automated transformation within OSI, allowing data to be loaded and transformed efficiently without unnecessary movement. Manual ETL via scripts is error-prone, time-consuming, and does not scale effectively. Offline RMAN restore addresses only physical migration, not data transformation or integration. Data pump exports and ports data efficiently but provides limited transformation capabilities. ELT enables transformations at the target, optimizing resource utilization and providing flexibility for heterogeneous source systems, aligning with modern data integration best practices. Question 10. In light of recent developments, ISTA Ibrahim must ensure secure migration of sensitive financial data to OSI while maintaining compliance with industry standards. Which strategy best addresses both security and integrity? A. Unencrypted data pump export over public network. B. ROMAN backup with TDE, encryption and OSI object storage transfer. C. Manual CSV export with local file transfer. D. Golden Gate replication without encryption. Answer. Correct answer. A. Explanation. Unencrypted exports over public networks pose severe risks for sensitive data, failing to meet compliance and security standards. Golden Gate without encryption similarly exposes data during replication. Manual CSV exports are insecure and prone to human error. RMAN backups with transparent data, encryption TDE, stored in OSI object storage are the best practice, ensuring both confidentiality and integrity during transit and at rest. This approach aligns with industry security guidelines, maintains compliance, and supports secure, auditable, and reliable migration of critical financial information to OSI. Question 11. Under the assumption that ISTA O'Connor is migrating large, mission-critical on-premises database to OSI, he notices intermittent network instability during transfer. Which approach best mitigates the risk of data corruption or incomplete migration? A. Use Oracle data pump over the unstable network. B. Employ the data transfer appliance for physical data transport. C. Manually copy SUL crypts and run them sequentially. D. RMAN backup over VPN during peak network hours. Answer. Correct answer. B. Explanation. The data transfer appliance is designed for large-scale, high-volume migrations and mitigates network instability by physically transporting data, ensuring integrity and completeness. Data pump over an unstable network risks failed or partial transfers requiring rework. Manual SUL crypts are labor-intensive, error-prone, and infeasible for large datasets. RMAN or VPN could face timeouts and network interruptions, making it unreliable under unstable conditions. Physical transfer via the appliance preserves all database objects and ensures minimal disruption to production operations, aligning with best practices for critical database migration. Question 12. From a practical standpoint, Martinez is planning a migration of an OLP workload with strict uptime requirements. She must evaluate downtime tolerance, database size, and version compatibility. Which tool or method provides the most comprehensive assessment before migration? A. Oracle Data Pump Test Export. B. Cloud Pre-Migration Advisor Tool CPAT. C. Manual Schema Comparison in SUL Developer. D. RMAN Backup Validation. Answer. Correct answer. B. Explanation. The Cloud Pre-Migration Advisor tool CPAT analyzes source databases for compatibility with OSI, identifying potential issues with version, schema, or features, and provides actionable recommendations. Data pump exports only assess logical data extraction, not full compatibility. Manual schema comparison is limited, time-consuming, and prone to oversight. RMAN validation ensures backup integrity, does not address pre-migration compatibility or feature gaps. CPAT allows comprehensive planning, reduces migration risk, and supports informed decision-making, aligning with OSI migration best practices for complex workloads. Question 13. While examining data integration approaches, ISTA Singh is designing a mapping that must ensure consistent updates from multiple on-premises sources to an autonomous data warehouse. Which approach is optimal? A. Batch ETL once per week. B. Oracle Golden Gate for Continuous Change Data Capture CDC. C. Manual SQL scripts executed daily. D. Offline RMAN restore followed by data pump incremental import. Answer. Correct answer. C. Explanation. Manual SQL scripts, though precise, are inefficient and prone to error for continuous integration of multiple sources. Batch at once per week cannot maintain up-to-date data for analytics requiring timely insights. Offline RMAN restore is unsuitable for real-time or incremental updates. Golden Gate with CDC is ideal for continuously capturing changes, propagating them to the target database with minimal latency, ensuring data consistency across heterogeneous sources. Proper configuration ensures transactional integrity, reduces risk of data loss, and allows near real-time analytics, aligning with modern data integration strategies. Question 14. Given the circumstances, Mr. Johnson must migrate a EM of an on-premise CDE to an OCDE while ensuring minimal disruption to other PDBs. Which approach aligns best with multi-tenant database principles? They unplug the PDB and plug it into the Tark CDB. B. Perform a full RMAN restore of the entire source CDB. C. Export all data using data pump and re-import to the Tark PDB. D. Manually create objects in the target and insert data row by row. Answer. Correct answer. D. Explanation. Manually creating objects and migrating data row by row is labor-intensive, error-prone, and impractical for large EDBs. Full RMAN restores affect the entire CDB and may disrupt other POBs. Data pump export import is a logical option but may be slow and require downtime for large PEBs. Unplugging and plugging are usually the most efficient and aligned. Multi-tenant architecture, isolating the PDB while minimizing impact. In practice, careful planning and validation ensure object, privilege, and data consistency while maintaining operational continuity in multi-tenant environments. Question 15. Through careful analysis of migration workflows, ISLE must choose between RMAN and data pump for a medium-sized production database requiring a full structural and transactional copy. Which approach should she prioritize? A. Data pump export import for logical migration. B. RMAN backup and restore for physical migration. C. Manual replication using SQL crypts. D. SQL develop migration for ease of GUI operations. Answer. Correct answer. A. Explanation. Data pump export import is best for logical migrations, handling schema and data efficiently with flexibility for medium-sized databases, allowing transformations and selective object migration. RMAN physical migration is more suitable for large-scale, full binary replication but may involve longer downtime. Manual SQL replication is prone to human error, and so SQL Developer is effective for small, non-critical migrations but not ideal for production-scale transactional systems. Data pump provides robust performance, supports parallelism, and allows post-migration verification, ensuring data integrity and alignment with OSI migration best practices. Question 16. In the context of secure migrations, Mr. Gomez is moving financial data to OSI and needs to comply with industry regulations for encryption. Which strategy ensures secure transfer and storage? A. RMAN backup with transparent data encryption TE stored in OSI object storage. B. Manual CSV export over the internet. C. Data pump export without encryption. D. Golden Gate replication with default network settings. Answer. Correct answer. B. Explanation. Manual CSV exports over public networks are insecure, susceptible to interception, and non-compliant with regulatory standards. Data pump without encryption does not provide confidentiality in transit. Golden Gate replication without encryption exposes sensitive information during replication. RMAN backups with transparent data encryption (ED) is stored in OSI object storage ensured data encrypted both at rest and in transit, aligning with best practices for compliance with financial industry regulations. EDE protects against unauthorized access while maintaining integrity and recoverability during migration. Question 17. From multiple perspectives, O'Neill is designing hybrid data integration flow between on-premises and OSI autonomous database. Which architecture optimally minimizes movement and enhances transformation efficiency? A. Traditional ETL with pre-transform on premises. B. ELT approach using Oracle data integration mappings. C. Manual SQL scripts for data transformation after full load. D. RMAN backup and restore followed by ad hoc scripts. Answer. Correct answer, C. Explanation. Manual SQL scripts are inefficient for large-scale integration, requiring repeated adjustments and prone to human error. Traditional ETL processes extract transform load externally, moving large volumes unnecessarily. RMAN backup restore is designed for physical migration, not transformation. ELT architecture implemented via Oracle data integration mappings loads data first and transforms it in the target, minimizing network movement, leveraging OSI compute resources, and supporting scalable, repeatable integration workflows. ELT improves efficiency, ensures data consistency, and aligns with modern cloud-native best practices. Question 18. While evaluating OSI database services, Mr. Davis must select a service that supports automatic scaling, built-in patching, and mixed workload management for an analytics-heavy workload. Which service is most appropriate? A. Autonomous data warehouse AppWare. B. Base database service without automation. C. RMAN managed standby database. D. On-premises clone managed SQL developer. Answer. Correct answer, D. Explanation. Autonomous data warehouse AppWare supports mixed workloads, built-in automation and elasticity, making it ideal for analytics-heavy workloads. Base database service requires manual management, increasing operational complexity. RMAN standby is intended for disaster recovery, not active workload handling. On-premises clones lack cloud-native features and automation. Selecting a fully managed OSI service ensures optimal resource allocation, automated patching, and integrated analytics support while reducing administrative overhead. Aligns with modern cloud principles, enabling performance tuning, high availability, and data-driven insights without manual intervention. Question 19. Considering the evidence, Instapark must migrate a multi-platform database with different operating systems and endian formats. Which strategy addresses this cross-platform scenario effectively? A. RMAN cross-platform transportable backup and restore. B. Data pump logical migration within the same platform. C. Manual SQL scripts replication. D. Offline RMAN restore without conversion. Answer. Correct answer, A. Explanation. RMAN cross-platform transportable backups enable migration between different operating systems and endian formats, preserving full database structure and minimizing downtime. Data pump logical migration works well within the same platform but requires significant time for large databases. Manual SQL scripts are labor-intensive and error-prone. Offline RMAN restores without cross-platform conversion fail when source and target systems differ, leading to incompatibility. Cross-platform RMAN migration ensures data integrity, maintains database consistency, and provides automated platform-specific conversion, aligning with Oracle's best practices for heterogeneous migrations. Question 20. In the modern context of database migration, Alvarez needs to ensure post-migration validation for an OSI autonomous database. Which approach best verifies both data consistency and application functionality? A. Automated validation scripts and checksum comparison. B. Manual spot checking of selected tables. C. Trusting RMAN restoration logs alone. D. Full data pump export without re-import. Answer. Correct answer, A. Explanation. Automated validation scripts with checksum comparison ensure thorough verification of data integrity and consistency between source and target, while also confirming that application functionality remains unaffected. Manual spot checking is limited, error-prone, and insufficient for production-scale database. RMAN logs indicate backup and restore success but cannot guarantee application-level validation. Full data export without re-import does not test end-to-end migration or functionality. Automated validation aligns with best practices for post-migration assurance, supporting audit readiness, reliability, and operational confidence in the OSI environment. Question 21. In the context of a migration project, Baker needs to migrate a high-volume old database to OSI with minimal downtime. Which approach provides the best balance of zero downtime and data integrity? A. Offline RMAN backup and restore during maintenance. B. Oracle Golden Gate replication with change data capture CDC. C. Manual export import via SQL crypts. D. Full data pump export import over the network. Answer. Correct answer. B. Explanation. Oracle Golden Gate with CDC enables real-time replication, allowing source and target databases to remain in sync, which is essential for high-volume OLP systems requiring minimal downtime. Offline RMAN restores involve significant downtime, risking business operations. Manual SQL crypts are error-prone and impractical for large datasets. Full data pump export import can introduce extended downtime and network dependency. Golden Gate ensures transactional integrity, near-zero downtime, and continuous availability, aligning with best practices for mission-critical database migrations in OSI. Question 22. Through careful analysis of migration evaluation considerations, Isa Patel is assessing a database with multiple schemas, large lob data, and limited bandwidth. Which method optimizes migration efficiency? A. Data transfer appliance for physical transport. B. Full data pump export import over the network. C. RMAN backup over VPN. D. Manual SQL export of each schema. Answer. Correct answer. A. Explanation. For databases with large lobs and limited bandwidth, physically transporting data using the data transfer appliance reduces network dependency, ensures completeness, and speeds up migration. Full data pump over the network may be slow and risk interruption. RMAN backups over VPN face similar latency issues and could extend downtime. Manual SQL export is infeasible due to complexity and size. The appliance approach preserves integrity, supports high-volume transfers, and aligns with Oracle's recommendations for large-scale migrations where network bandwidth is bottleneck. Question 23. From a practical standpoint, Istachen is evaluating migration options for a multi-tenant CDB containing several EEBS. Which strategy allows him to migrate a single PDB without impacting others? A. Full RMAN restore of the near CDB. EPDB unplug plug into the target OCDB. C. Data pump export import of the PDB. D. Manual schema recreation and data insertion. Answer. Correct answer. C. Explanation. Data pump export import of a single PDE allows selective migration without affecting other PES, maintaining operational continuity. Full RMAN restores would impact EES and EE unplug plug is also suitable but may require downtime and additional pre-migration steps. Manual schema recreation is labor-intensive and prone to errors. Data pump provides a controlled migration path, preserving schema, data, and privileges, enabling safe, efficient migration of specific PBS in multi-tenant architectures while adhering to OSI best practices. Question 24. Given the circumstances, is Rivera needs to integrate multiple heterogeneous sources into an OSI autonomous database with minimal latency. Which architecture best supports this requirement? A. Traditional ETL with batch processing. B. ELT using Oracle data integration mappings. C. Manual SQL scripts executed weekly. D. RMAN backup and restore followed by data pump. Answer. Correct answer. D. Explanation. RMAN backup and restore followed by data pump is not ideal for heterogeneous data integration or low latency requirements. It is primarily for migration. Traditional ETL and manual SQL scripts introduce delays and limited scalability. ELT architecture using Oracle data integration mappings allows data to be loaded first into the target and transformed there, leveraging OSI compute resources, minimizing data movement, and supporting near real-time updates. ELT enhances efficiency, maintains consistency, and aligns with cloud-native principles for integrating multiple sources effectively. Question 25. When analyzing migration performance, tuning is to notice slow data pump operations during a large schema migration. Which adjustment is most likely to improve performance? A. Increase parallelism and optimize network throughput. B. Reduce buffer size and limit parallel jobs. C. Execute migration during peak business hours. D. Disable compression options. Answer. Correct answer. A. Explanation. Increasing parallelism and optimizing network throughput directly enhances data pump performance by enabling simultaneous processing of multiple data streams and reducing transfer bottlenecks. Reducing buffer size or limiting parallel jobs decreases efficiency. Performing migration during peak hours can exacerbate contention with production workloads. Disabling compression may increase network traffic without bottlenecks. Properly tuning data pump parameters, including parallelism and network configuration, aligns with OSI best practices for high-performance migrations while minimizing overall execution time. Question 26. Through the lens of secure migration, Santos must ensure encrypted data transfer and compliance during migration of sensitive healthcare data to OSI. Which strategy is best? A. Arman backup with transparent data encrypt and IDE stored in OSI object storage. B. Manual CSV export over FTP. C. Data pump export without encryption. D. Golden Gate replication with the SSL. Answer. Correct answer. C. Explanation. Data pump export without encryption fails to protect sensitive data in transit, violating compliance standards. Manual CSV exports are insecure and prone to interception. Golden Gate replication with the SSO exposes data during replication. Arman backups with TD stored in OSI object storage provide encryption at rest and in transit, maintaining regulatory compliance and integrity. Proper configuration ensures auditability and reduces risk of unauthorized access, making it the recommended approach for sensitive workloads migrating to OSI while adhering to best practices in healthcare data security. Question 27. Considering the evidence Ista Thompson is planning a cross-platform migration between databases with different operating systems and endian formats, which approach effectively addresses compatibility? A. Arman cross-platform transportable backup and restore. B. Data pump export import within the same platform. C. Manual SUL scripts replication. D. Offline Arman restore without conversion. Answer. Correct answer. B. Explanation. Data pump export import within the same platform is limited to logical migration, incapable of handling cross-platform endian differences. Offline Arman restores without platform conversion will fail due to binary incompatibility. Manual SUL crypts are inefficient and error-prone for large databases. Arman cross-platform transportable backups handle differences in operating systems and endian formats, converting the database as needed and preserving object integrity. This approach ensures successful migration across heterogeneous environments, aligns with Oracle best practices, and minimizes downtime while maintaining database consistency. Question 20. In the modern context of OSI, database services is new and must select a database for mixed workloads requiring automation, scaling, and analytics. Which service is most appropriate? A. Base database service with manual management. B. Autonomous transaction processing app. C. Arman standby database. D. On-premise SUL developer managed clone. Answer. Correct answer. D. Explanation. Autonomous transaction processing app supports mixed workloads, automated scaling, and built-in patching, making it ideal for cloud-native applications. Base database service requires manual configuration, increasing operational overhead. Arman standby databases are for disaster recovery, not active workloads. On-premise SUL developer clones lack cloud automation and elasticity. Selecting app aligns with OSI principles, reduces administrative burden, supports high availability, and provides analytical capabilities while ensuring optimal performance for mixed transactional and analytical workloads. Question 29. With respect to data migration planning, Ista Ibrahim needs to verify post-migration integrity and application functionality. Which approach is most thorough? A. Automated validation script with checksum comparisons. B. Manual spot checking of random tables. C. Trusting Arman logs alone. D. Full data pump export without reimport. Answer. Correct answer. A. Explanation. Automated validation scripts with checksums provide comprehensive verification of data integrity, ensuring that all tables, schemas, and transactional data match between source and target. Manual spot checks are insufficient for large databases. RMAN logs confirm backup success but do not validate application functionality. Exporting data without reimport does not test post-migration consistency. Automated validation aligns with best practices, confirming end-to-end migration success, supporting audit readiness, and verifying that the migrated environment meets functional and business requirements. Question 30. At the heart of this issue is Alvarez must migrate multiple REBS from on-premise CDBS to CDBS while minimizing downtime. Which migration approach balances efficiency and continuity? A. PDB unplug plugin to Targ CDB. B. Full RMAN restore of all CDBS. C. Data pump export import of each PDB sequentially. D. Manual schema recreation and row burrow insertion. Answer. Correct answer D. Explanation. Manual schema recreation and row by row insertion is impractical for large PDBS due to time and error risk. Full RMAN restores in back to all PDBS and require downtime. Data pump sequential exports are slow for multiple large PDBS. Unplugging and plugging PDBS efficiently migrates individual containers while preserving isolation, metadata, and privileges minimum. Disruption. Pre-migration validation, testing, and resource planning ensure data integrity and continuity. This approach leverages Oracle multi-tenant architecture principles, balancing efficiency with minimal downtime for production workloads.